Hello, fellow geometry people. Today I'm going to be proving the distance formula using a coordinate graph. I've plotted some points and I will show you how to use the distance formula through this video. Since we're going to be working with a triangle, we will also be using the Pythagorean theorem along the way. For the purpose of this video, I'm going to be relying on two Pythagorean theorem triplets, meaning for a 3, 4, 5 triangle, 3 squared plus 4 squared will equal 5 squared. And for a 5, 12, 13 triangle, 5 squared plus 12 squared will equal 13 squared. The first example I will be using is triangle HEY. We know that line segment EY, or A, is 3, and line segment EH, or B, is 4. But we are going to prove that C, or line segment HY, is 5 units on triangle HEY. The Pythagorean theorem will help us get the distance of HY. Some more information about 3, 4, 5 triangles is that they have to have a right angle, which in our case is angle HEY, as shown. We know this is a right angle because the slope of line segment EY, using reservoir run, is 0/3, which is perfectly horizontal. And the slope of line segment EH is 4/0, which is an undefined line, but perfectly vertical and perpendicular to EY. So that is why our two perpendicular lines, EH and EY, form a right triangle. So using the Pythagorean theorem, we're now going to substitute for each of the line segments. So we would do 3 squared plus 4 squared equals c squared, because we don't yet know what c squared is. So 3 times 3, 9, 4 times 4, 16. Then 25 equals c squared. But we have to undo the squared, so we're going to square root both. So our final answer is 5 does indeed equal c. Now we can solve the same exact problem but with the distance formula, so we can check the answer. So we can put the coordinates 3, 4, and 0, 0 in the distance formula to find what the distance of c is. So we can call 3, 4 x1, y1, and 0, 0 x2, y2. Because the distance formula is square root of x1 minus x2 squared plus y1 minus y2 squared. So we can substitute those with the coordinate points, which would be 3 minus 0 and 4 minus 0. Then we just have to square the numbers. So it would be the square root of 9 plus 16, which is 25. The same answer we got just with a different method, the distance formula. So the square root of 25 is 5, which is the exact same answer as we got last time. And that would equal c equals 5 units. So the distance formula, which we just worked with, comes from the Pythagorean theorem to find the hypotenuse, or c. The distance between 2 points is one straight line, and the distance formula condenses the Pythagorean theorem, or a squared plus b squared equals c squared, into leg squared plus leg squared equals the hypotenuse squared, which can work to find any distance of lines in a triangle. So now the biggest question. Why does the distance formula work? Well, the x2 minus x1 in the formula stands for the horizontal line because it finds what the distance is between the x coordinates. And the same goes for the y2 minus y1, only it finds a distance between the y coordinates, which is the vertical line. And the distance can never be negative, it will always be positive. The squaring and adding of the x and y coordinates in the formula only gets the distance squared. So we have to undo the squaring to get the exact distance of the line we're looking for, which is why we then square root in the formula. So this is why we use the distance formula in geometry and how it works. And when we are looking to find the distance between 2 points, you need to find the slope, or the rise over run. As you can see, it's x over y. And this step makes a perfectly right triangle to use the distance formula.